welcome everybody. Before we get underway, we've got a lot of registrations from all corners of the country, so we'll just wait a couple of minutes for everybody to settle in. I hope you've all got a cup of tea or a cold beverage at hand, and yeah, we'll get underway shortly. Again, as some of you have just joined us, welcome, and thank you very much for getting on board with this very unique presentation to share with you the journey of Clima in New Zealand and the introduction of these wonderful products, obviously including INTELLO. So sit on in and hopefully you enjoy the event. The reason behind this event is obviously the recent BRANZ appraisal of the INTELLO vapor control and airtightness system, the first of its kind to be BRANZ appraised in New Zealand, which is very exciting for us. So hopefully the team will cover off a lot of your questions that have already been submitted. And on that note, if you do have any burning questions that you'd like to ask the team that's with me today, feel free to drop those questions into the chat window on the side of your screen. And hopefully, if we get a bit of time at the end of the presentation, we'll tackle those questions then. This event gives you the opportunity to get an insight into the journey that we've been through over the last dozen plus years operating in the New Zealand market. And some of the good, the bad, and the ugly moments in part of that journey. So hopefully you enjoy it and you can see a lot of the hard work that the team have put in over the years to get us to where we're at the moment. So yeah, we have most of the sales and tech team online, as well as our fearless leader, Thomas, which most of you probably have seen about the traps in the last few years. We will like I say, hopefully tackle all of these burning questions that you have. And we've got some supporting slides to support the answers to these questions. But like I say, if you've got any other questions that you want to ask, feel free to drop them into the chat window and we'll hopefully tackle them towards the end of it. With all of our previous online events, your camera and questions will not be shown to the audience. We are, however, recording the session, but like I say, your camera won't be shared as part of that recording. So feel confident to submit any questions. We've got poll questions as part of the presentations, which is questions from us to you. So feel free to confidently answer those as you wish. Cool. As part of the panel joining us today, obviously, as I mentioned, we've got Mr. Thomas van Raamsdonk, our Chief Executive, not only for New Zealand, but as well as Australia. You may have seen Thomas recently online in a video that was posted on LinkedIn. He also runs with the alias Dr. T. Quite fitting, Thomas, in that video, you're wearing your lab coat and spectacles. So yeah, looking forward to your presentation. We've got Catherine McGregor, our regional sales representative, based down in the beautiful Central Otago region, who will also be presenting today. We've got Richard Eden, our regional sales representative, looking after the Upper South Island, as well as the Wanganui and New Plymouth region. Rich has just recently been poached out of the technical team to get back on the road as a sales representative. So looking forward to his involvement in the sales team. Rich is also just about to relocate back to his hometown of Wanganui, so no doubt you'll see him around the building sites and architectural practices. Richard's sidekick in the Lower North Island, we've got Mr. Soren Webb, our Lower North Island regional sales representative. Soren's based out of our head office in Wellington, and like I say, looking after the Lower North Island. Our Auckland crew, first up we've got Richard Hollard, who's our architectural specifications manager, and Simon Cator, who's our Upper North Island regional sales manager. No doubt you would have seen these two on LinkedIn. They're our in-house LinkedIn gurus, and if you're not connected to either of these two, no doubt they'll hunt you down and you'll be connected in the not too distant future. Heading up our technical team in New Zealand, we've got Anthony Rewa. Anthony, no doubt you might have seen him around the traps as well, very familiar face from the industry. Anthony looks after all of the technical support for the sales team, product development, and also the education and training side of things for Clima in New Zealand. So good to have you online today, Anthony. Hopefully I haven't missed anybody. Obviously myself, another Simon, but I prefer to be run with Si. I'm only called Simon when I'm in trouble from my wife or from my mother. I head up the sales side of things as a national sales manager in New Zealand, and am based in Canterbury. And if you are from Canterbury, no doubt you may have seen me around the traps as well. I look after the day-to-day business and sales and architectural support in the region as well. Behind the scenes, and I wish we had their cameras showing today because they would definitely, apart from Kat, lift the attractiveness of the bunch we've got in front of you. We've got Eva, who heads up the marketing and communications team, and supported by Sandra and Natalie, who've done a lot of hard work behind the scenes to make this event happen. Rightio. I know most of you will be fairly familiar with the Clima range of products, but I'll just quickly go through our offering. The other thing that I want to point out, and again, most people are pretty aware of it, but we're a 100% subsidiary of Clima in Germany, which is the manufacturer of all these wonderful products that we have on offer in the New Zealand market. So it's a very, very fortunate position that we're in, having that reach back to the technical and marketing team and product development team in Germany. And as well as these testing times that we're in at the moment in regards to material supply, having good connections with the distribution team in terms of consistency of supply of these types of materials in the market. So it's a very, very fortunate position that we are in compared to a number of our competitors. So first up in the product offering that we'll run through is our Solitex X Designer, which is our staple-on synthetic wall underlay, and obviously the system products that go with that. Sticking with the wall, we have got the Solitex Adhero, which is our peel and stick underlay. It's a relatively new product to us, quite commonly used commercial applications where it's fully adhered to a substrate. Also used in the SIPS panel market, CLT, where you are adhering the wall underlay directly to a substrate. With the Adhero, it can also be used in the roof application. This particular product, as well as the staple-on version, has 180 days UV exposure. And the feedback from the market at the moment with the delays around cladding supply and bits and pieces, it's a very good product to have in terms of keeping the construction dry whilst waiting for all of your cladding products. Moving to the roof, the first of the products is our Solitex Mento range, which consists of the Solitex Mento 3000 and the Solitex Mento 1000. I won't go into too much detail around this because we do have a number of questions regarding the Mento underlays. The basic difference between the two is the thickness, which has a bearing on the structural strength and the UV exposure of the products. Sticking with the roof, and this would have to be one of my favorite products outside of the INTELLO, is the Solitex Connect. This is a specialist Euro tray underlay designed to support the wide pan Euro tray product to allow for expansion and contraction and minimizing oil canning. So very, very good product. We sell lots of it. We also offer this particular product in separate mesh layer, so it can be used with all sorts of cladding materials and wall or roof applications. Moving to the inside, and again, I won't go into too much detail about this particular product because this is the backbone of what we're here online to see today, is our recently BRANZ appraised INTELLO airtightness and vapor control layer for the inside of the building. So I'll leave it at that, and hopefully we'll go through a lot of the technical aspects and information around the product shortly. Overall system, as you see, with all the different accessory products on the outside, we've got all solutions for tapes, window connections, glues, pipe and cable penetration grommets, and all the accessory products that go with the internal and external products. Just jumping around the outside of the page, we've got our code mark certificate, which applies to the Solitex X Designer, the staple-on wall underlay, our BRANZ appraisal, which applies to a majority of the external weather tightness products, and obviously the recently appraised INTELLO internal air tightness and vapor control layer. The blower door, this is something that is fairly unique. We're the Australasian distributor for the Minneapolis blower door, which is a device that's used for air tightness testing of the building envelope. I do say if you ever get the opportunity to sit on a blower door test, definitely take it up. It's quite an exciting way to see how a building envelope performs, and even better if you're blower door testing a house that hasn't got a dedicated air tightness layer to see where the amount of leaks come through all sorts of areas of the building. Fortunately enough, in regards to the blower door, we've got a lot of blower door operators scattered throughout the country. You can see or contact them, or their contact information is on our website in the resource centre. So if you do need a blower door test, jump on our website and you can find the contact information to your nearest blower door operator. The bottom logo on the bottom right-hand side is our 100-year adhesion. This is something that we are very proud about. We've just recently gone through some extended adhesion testing on most of our internal and external felt-based tapes, and they've passed with flying colours to be, which were tested to the 100-year mark. So it gives you confidence in terms of the use of the product that they will stay stuck for a long period of time. Moving to the left-hand side of the page, we've got, which would have to be one of my favourite and most proud things, is the Declare certification and Red List free. What this means is it's an online register for building material manufacturers that produce products without any nasty toxic ingredients. We take pride in this, that all of our products don't have any of these nasty ingredients. The ingredients list is available on the Declare website, which consists of approximately 820 ingredients that are commonly used in building materials today. Things like your formaldehydes and what have you that may emit VOCs. So if you are interested, jump on the Declare website and you can find all the information on there. The second to last one is the Passive House certification. This applies to a majority of our internal air tightness products. What this means is it helps streamline the process in terms of designing a certified passive house building. So again, it gives you confidence in terms of the materials that you're specifying. And last but not least, the sensitive choice, which is through the Asthma Foundation in New Zealand and Australia, which applies to internal air tightness system being the INTELLO. So I think I've covered the lot. Right, Thomas, now before I hand the reins over to you to run through your side of things, I've got a bit of a question for you in regards to our relationship. Obviously, some of you might be aware, I've worked with Thomas for a number of years, and I believe it must be 17, 18 years now when we first met in the timber industry. And back then you're engaged with Clima, looking at potentially introducing these products into the New Zealand market. Back then, Thomas, I dare say we were a bit more sprightly than we are now, and I'd say we had a lot less greys, to be fair, but you were very, very passionate about these products back then, and you've followed your passion and you've introduced these products into the New Zealand market. Do you still have a lot of that passion, and how do you feel about things, how it's changed now and how the industry's changed, and we're staring down the barrel of the building code changing as well?
Yeah. Hey, thanks for the introduction and the overview that you've given us all. It's I have to say that every day I still get up in the morning, I think I have one of the best jobs in the world, because we're so far behind in terms of performance of buildings still. And I do remember 2003 when I first came to New Zealand, just looking at the performance of houses and how things were detailed and built, it was quite surprising how low the performance was. And what was really interesting at the time was that Lothar Moll, the owner of Clima out of Germany, he was in South America, and I told him that, you know, you're in South America, just hop on the flight, just one flight from Santiago de Chile, and you'll be in Auckland, and I'll just show you what's happening here. I still remember Lothar arriving in Auckland, being not pleased that he was on a 14-hour flight over Antarctica, basically, And the word he used the most in those 3 days he was in the country was how unbelievable everything is. So how unbelievably friendly the people are in New Zealand, how unbelievably beautiful the country is, and how unbelievably shocking the performances of houses. And that was really the start of the of Proclima here in New Zealand to really drive it. And the passion hasn't dropped really since then. So I'm glad to see that the INTELLO also is now BRANZ Appraisal and is becoming more of a norm. So we see a lot of construction. Back in the days, it was really, just some isolated customers who were thinking above code, and now it's actually becoming a norm, which is great.
Fantastic, fantastic. Oh, well, I'll hand things over to you, Thomas, to give us a run through of Proclima in New Zealand, as well as the process that we've been through over the last 12, 13 years in terms of introducing INTELLO into New Zealand.
Yeah, with the introducing the whole range of products into New Zealand, we went through a few key steps along the way. So if I can have the first slide, please. So as part of our overview on the New Zealand market, we actually started quite early on in writing this New Zealand study. So there's a link there to the website that's available as a download. I think from memory, the first print was about 20,000 copies, and we handed out copies to anyone and everyone who wanted to take some. Maybe some people took some boxes for the wood burner, but that was okay to start with. The study really covers some of the basics of building science, how it applies to the various New Zealand climate conditions, and what the issues really are. So we highlighted that in 2011, and there has been a revised study in 2020 that came out with a few updates, but it's still available. And I've actually used it extensively during lectures and workshops, also at universities I've been running. So it's been a really great tool, and I think a lot of people are still using it. Moving on from the study, we had a situation that you might still remember down in central Otago with Pete Lawrenson, who was at the time running Lakes Environmental, the organization who was dealing with building consenting. And they had a lot of issues with skillion roofs. They were leaking, and I remember seeing roofers on the roof hosing down the roofs, demonstrating that the roofs were watertight from the outside, but you still had the water dripping down through the downlights. And we came up with a solution which basically is the INTELLO to prevent the warm air of the moisture going into the roof, into the skillion roof, to then condensing out. And so we went through, we had a couple of building sites where INTELLO was specified through the early adopters of some of the architectural practices in Central Otago. And then, of course, we went through the consenting process. RFI came back and said, well, what is this whole thing? How can this comply with the building code? And so from our end, we actually then talked to Pete Lawrence, or actually Pete Lawrence contacted us and say, hey, Thomas, this is getting so complicated for me and my team. Can you come down there and run a workshop? And also maybe we can go through a determination. So I had no idea what the determination was at the time. And the determination was through within a couple of, it was actually 4 weeks, I think, 4 or 5 weeks. And I think the positive outcome was that both local building authorities, back then the Department of Building and Housing, and us and the clients and the architects and designers were all happy with the outcome. And that was really a milestone. And as I said, the outcome was a WUFI workshop that we ran locally for the members of council. After the council workshop, we thought, well, this should actually go further. So in 2012, we ran the first WUFI workshop in Australasia. That was done in Wellington in the Botanic Gardens in the tree house. It was a great location. In hindsight, it wasn't really good because it was so noisy with all the birds in the Botanic Gardens. But it was a great collaboration between Fraunhofer Institute of Building Physics, who invented WUFI. So we had Manfred Kehrer coming over from Germany. We also had Stephen McNeil presenting from BRANZ. So until today, BRANZ is the research partner of Fraunhofer for WUFI. and ProClima continues to be the cooperation partner. So from now on, we run the WFI workshops for architects, designers, engineers, anyone who wants to upskill in building physics, and also provide the technical support for that one. But that was a milestone for us. We also ran it at the Wigram Air Force Museum, I think, and there's a few jokes around that thanks to the Germans, there was an Air Force Museum and we could run a WFI workshop by Germans again. We continued that in 2016. BRANZ conducted some more research into interstitial condensation problems in walls in New Zealand. So there was the study report 344. It was published in 2016 by Greg Overton. And there was one wall involved, if you read through the study report, that doesn't show the negative effects of interstitial condensation. Of course, they couldn't call the product name, which would have been INTELLO. So they came up with a new term called SVR, or Smart Vapor Retarder, which didn't really help for everyone in terms of just getting used to new words, because in Europe, in the UK, for example, the INTELLO is called Vapor Check, and our BRANZ called a Smart Vapor Retarder. I think the marketing team from ProClima called it the IAB, the Intelligent Air Barrier Systems or something, or IAS, sorry. And now we finally have actually zoned in on what we can see here is IAB, so the Intelligent Air Barrier. So that hopefully makes sense, and we're going to go into more detail over the next few slides and presentations then. And of course, it all accumulated in the BRANZ appraisal that was published this year, beginning of this year, and it's been in the making for quite some time. But as you can see from all the steps, certain things needed to happen, and we have a long service history now of the INTELLO in use in New Zealand. And it's not just in Central Otago anymore. We see actually a lot of uptake of the INTELLO in the Auckland region as well, because of the climate conditions where you have high temperature, high humidity, perfect breeding ground for mold. So yeah, it's been a long journey, and as you said, some hairlines retreated, some color changed into white. So we've come a long way over the past decade and a half.
Absolutely. Just as we go through the presentations or the event today, there will be some links added in the chat channel to links for you to download bits and pieces. So do feel free to download or attach or click on those links, and we'll have all the relevant information for you. Right, poll question time, Thomas. Let's see what the first question is for people to answer.
So quick poll, first one. Do you think the BRANZ appraisal of INTELLO will assist you with the consenting process? So there's 3 answers that you can select, either yes, no, or not sure. So what you can do, you just click on one of those 3, and that will go through to the summary of the polling.
Fantastic. As Thomas mentioned, please do hit submit, and your answers will come through, and we'll hopefully get an indication of where we're at.
So we see the answers coming through, where we have 89% saying yes, so the INTELLO BRANZ appraisal will help with the consenting process, hopefully no further RFIs. 7% said no, and 4% are not sure.
Wonderful. Hey, thanks for your assistance there, Thomas. Right, we've got some questions from the public for you now, Thomas, to answer. So we'll just scoot through to those now. So the first one, when was INTELLO first invented, and what were the breakthroughs in its development?
Maybe taking a step back, so what you can see there on the right-hand side of the screen, it says ProClima DV+, so capital D, capital B, and then the plus. It was actually the predecessor of INTELLO, and that was developed in 1994, so quite a few years ago, when cellulose, so insulation was blown into cavities, and for keeping them in the cavity, they need to have something to help. And that's where the DB Plus came from. So in 1994, Fraunhofer Institute of Building Physics actually measured a product like the DB Plus and figured out it had what we call a humidity variable function. So it had the smart part within the membrane. And the INTELLO came 10 years later. So the DB Plus has a certain performance criteria. or characteristics really, not criteria. And the INTELLO is actually further development on the DB Plus to give us a wider range. So it's tighter when it needs to be, and it's more open when we need to have the back diffusion of the moisture come out of the construction. So it's, yeah, the INTELLO was 2004, first time in the market worldwide, but it goes back to 1994 in terms of technology.
Wonderful, thank you. Just so people are aware, the DB Plus we do carry in stock in New Zealand. It is still available and it is still used here. So if anybody is interested in that particular product, please feel free to reach out to one of the team. Another question coming through for you, Thomas. What's the difference between an air barrier and a vapor barrier?
These are two fundamentally different performances. However, you can have everything in one. So starting off with an air barrier. So an air barrier could be anything that stops air movement through the actual material. There could be a sheeting material. I mean, it could be all sorts of different things that are what we call airtight. But the thing is that in the past, for example, plasterboard was looked at maybe using as an airtightness layer, and the plasterboard in itself is airtight, which is correct. However, we have a lot of penetrations through the sheeting material through that plasterboard. If you think about light switches, power plugs, corners, risen off the ground. So the question really is about air barrier systems, so it needs to be more than that. A vapor barrier is normally a plastic sheet or something that has a high SD or MVTR value. So what it means is that the higher normally the number, the more resistive it is for moisture to go through. So air barrier is about stopping air flow, and a vapor barrier is stopping moisture flow. But it's important to understand the INTELLO is not a vapor barrier. The INTELLO is a humidity variable barrier that allows moisture to go through when it needs to, and protects structure from moisture when it needs to protect it. So INTELLO is slightly different. It combines the air and vapor control, but it's not an air barrier or a vapor barrier. It's something combined.
Thanks for that, Thomas. And that last bit is actually a very common question that we get asked all the time in terms of the confusion around, is the INTELLO a vapor barrier or what is it? So thanks for clarifying that. Next question, which I find quite good. What influences can such products have on the update of the New Zealand Building Code?
Just to answer this question quite quickly, all clauses have to come together. So what we see at the moment with the proposal was put out by MB around the R value changes under H1, so the energy efficiency, that's just one component of the overall performance of the building envelope. Under H1.33, it already talks about airtightness, and I think we'll come back to that topic a bit later. We will see blower door testing, airtightness layers, moisture control layers, together with WUFI, with the software simulation tool, being part of the package of improving the overall performance. But all clauses need to come together. It's not just one thing, and it will have this magic. It's not the magic bullet to solve all the problems.
Absolutely. Thanks for that, Thomas. It's really good to see the people registering or registered for this event asking these questions. So I thank you if you're online today. Thank you for submitting these questions for the team to answer. Now, Thomas, talking about questions, we've had a lot around what was the first project that featured INTELLO, what was the first commercial, what was the first school. So what I've done in discussion with you is we've compiled 3 particular projects from the early days of the ProClimate New Zealand and somewhat the most memorable projects as well. So the first one we have on our screen, Thomas, you are heavily involved in, and I'll let you explain and run people through what this project was and what it was about.
Yep. So this, while I remember this very well, is that this is the first light house that was done through Victoria University School of Architecture. So there were 4 students who were submitting their plans to be part of the Solar Decathlon, part of the energy department in the United States. And this was an amazing project to be involved in, where a bunch of students from New Zealand, where we have, let's say, not the most highly performing buildings in the world entering into the solar decathlon, being selected. They off-site manufacturers have prefabricated the house. It was on Frank Hitz Park in Wellington for a period of time for people to visit. And then it was dismantled, shipped to the United States, set up in the Washington Mall. And I have to say, it was a really proud moment for New Zealand that I think nobody understood, because they came third overall, which is phenomenal. I mean, bronze. They came second from memory in architecture, because it's a beautiful design. It's based on a batch designed for New Zealand. And I have to say, with a bit of help from some people, they came first in engineering in terms of performance. So this house was absolutely stunning, and it is. And it was shipped back to New Zealand. It's in Hawke's Bay. Anyone on Book a Batch or something can actually book a night in there. And it's actually the 10th anniversary this year, or next year. And so the whole team is coming back together to stay. It's not big enough for the whole team to stay, but it was pretty amazing. But this was a great project. And if anyone wants to know more, the good thing out of this is that the 4 key students, together with lecturer Guy Marriage at Vic University, they started a company called First Light Studio, and they have an offshoot called Flip House, and they're doing Flip Homes. They're doing exceptionally well. So it's great to see the next generation of architects coming through and really taking it to a whole nother level.
Fantastic. I hope you've got that, got an invite for the celebration, Thomas.
Yeah, I'm not part of the core team, so.
Oh, okay.
That's all right. Let the young people celebrate.
The second project was, this is quite unique actually. This one, it was our first commercial project, and probably our first retrofit project. Some of you may be familiar with this building. It's the Cavell's building, looking down on the shot over jet operations. It is now retrofitted to a very high energy efficient standard, and is the home to Dock in Queenstown. So I think I was only about 3 or 4 weeks on board with ProClima when we did this project, but yeah, it's one of those ones that's stuck with me and very, very memorable.
I think it stuck with a lot of people because people started using the Orcon for the first time. It got stuck everywhere. Well, I'm glad we're not talking about jet bolting, Si. Thanks.
The last of the memorable projects is the Copper House in Queenstown. Now, this particular project would have to be one of the biggest residential projects that I've been involved in. I believe it was back in 2013, and we're actually just going through an extension to the building. So the drawings came across my desk about a month or 2 ago. So this particular project featured INTELLO, ex-designer, and some of the roof underlay projects. And if you are interested, you can stay in this building as well. You can jump on Sotheby's website. I think the going rate for one night is about $22,000 a night. Tom Cruise, I think, has stayed in this place. And I have been told by Birdie Thomas that we might have our Christmas do there. Is that correct?
Wow, wishful thinking. We might be tenting next to it.
Dreams are free, huh? Thank you very much, Thomas. We will see you back towards the end of the event. We've got some more questions coming your way. But our next presenter that's going to present to us on a very interesting recent project that's been happening throughout the country is Richard Eden. He's going to be presenting on the Kāinga or retrofit.
Yeah, Kāinga or retrofit project. It's a pretty big one across New Zealand, and there's a massive amount of planning at the start, which needed to take place, and a lot of understanding from the historic buildings which had already taken place. The retrofit program for myself has always been about creating a healthy environment that has for all families of every demographic and size in New Zealand. I always wanted and still want every family to be able to live in a healthy environment, safe place, shelter over their head, regardless of their situation, to make sure that they can thrive, thrive and do better and improve themselves and move into the pastures if they can. if we take an example of a family, like a real life situation. So let's take some families of different demographics and sizes, say mum, dad, 4 kids, 5 kids, 7 kids, one from the man or 2, sometimes it's 8 kids. And they've fallen on some hard times and they're all kind of getting together and might have been priced out of the market, out of the rental market. There's nothing available. You know, there's lots of things going on currently right now. And we all know it. These people are pretty ingenious, right? So regardless really of whatever the waiting lists are, what we have is we have these families and all these kids organising themselves into these single houses. And it's overcrowding, right? So the current stock available is not there. So one family gets one of these houses and then 3 families might move into it. Of course, not on paperwork, it's only one family going in there. But they organise themselves in there because, well, they need to have shelter. They do. You know, and that's the most important thing, is to have good shelter over their heads and keep safe. However, what history has shown with some of these builds is when that happens, we start to create a type of environment which isn't, you know, it's not really suitable. It supports the growth of some organic life forms and lets them flourish, like mold and a few other organic life forms. However, it's not the ideal, you know, environment for our children to live in. Luckily, the designers who were involved in the Retrofit pilot program, they know this, and for the aim to be able to create these warm, dry, healthy, safe homes for our families and children and everyone involved, they had to address this topic, you know, that and ventilation and heating and a few other topics. So this one was quite tricky. This is where we got involved with them, and from the start we said, look, you need to have a professional do a hydrothermal analysis on these for the regions and actually understand what's going to happen and, you know, plan for your occupancy to be a lot higher than normal. And that was the tricky part. However, luckily, Clima has been in the country for a little while, and we kind of know that our product, through history, throughout the last 17 years or so that it's been in New Zealand, we know that it works. So we did some modelling and found that yes, using INTELLO and the walls and where possible across the ceilings as a vapour control layer dramatically reduced the risk of mould growth in these buildings, even when there was high occupancy as well. And that's fantastic for the families involved because, and for the durability of the buildings as well, because we are maintaining these dry house safe environments for these children. So currently now, the estimate I think is we're up to about 1,000 retrofit houses in New Zealand nationwide. And we do train the installers on site when they ask, and we go on site and show them the fastest, easiest way to really nail these systems out. And it's been great to have these people on board and be willing to learn as well. The main point of this layer is to reduce the chance of mold growth, and that's why. And the guys involved are all really keen to do that because, well, everyone in New Zealand is kind of used to mold, everyone shouldn't be. However, now these state houses have got this intelligent vapour control layer. They're more airtight, so not only are they mold-free, they're also, you know, more energy efficient as well, so the power bills aren't as high, which is absolutely fantastic. So these families which are moving in, you know, these families which are moving into the buildings now, you know, mum and dad and 7 or 5 kids, they're not having to worry about the kids getting asthma from the mold and spores flying around, or bad health, or power bills which are sucking up all of their money, which they're already short on in some cases. They can actually start working towards better in the future. And for me, that has been just absolutely fantastic to be involved in with Kāinga on these houses and the builders and the electricians and plumbers, which are all involved in coming together to make sure that these buildings and environments are suitable. You know, they are safe and they're really nailing it, which is fantastic for New Zealand. I'm absolutely proud and stoked to be a part of it. Now that's all for me on the topic. Please, if you guys ever have any questions, contact us about these projects. More than happy to talk through them. So let's get back to you.
Yeah, hey, thanks for that, Rich. I just got a question from myself here. With the rollout of the Kāinga or Retrofit program, how have you found the willingness of these contractors that have won the tenders to do these projects in regards to installing the INTELLO?
Of course, it depends on the building company which has won the tender. You get some old school builders, you get some new school builders. What I've found is that all these guys are actually on board and making sure that these houses are done right for these families, and they've been really willing to understand how these control layers work and actually try and get it right. And one of the best parts, which I've found on every site I've been to or every different building company I've been with, is they're always trying to find different ways to increase the speed, make it faster, but still get it right as well. And I've learned from these guys as well, which has been fantastic. So pretty good response from the industry, really.
That's good to hear, mate. Fantastic. Hey, Rich, I've got a couple of questions for you that have been submitted. The first of them, it's from hometown, Canterbury. How do you best deal with pressure against the INTELLO membrane created by the likes of blown-in insulation, likes of the Jetstream Max that we see used in the market, and obviously in the skilly and roof, and I think we should answer the wall as well. So how do you prevent putting that pressure on the staples or damage without putting heaps of them in?
Yeah, tricky question, that one, because it's a question of how much weight or how much pressure is being applied to the INTELLO. And then it becomes down to a question of how am I going to fix this layer in place. So typically on a wall, you might have a surface cavity, which would then carry the weight of this pressure against the INTELLO. Skilly and roof, yeah, you might be packing out your ceiling battens and stuff, so you might not have these fixings in place. But that always comes back to how much pressure and weight you're going to be applying. There are possibilities for different types of fixings, plywood strips and these other types, so there is a range of different ways to do it. But normally this comes down to the designer looking at it and understanding how much pressure, how much weight am I going to apply to this layer? What is the best way to fix it? As I said, talk to the team, mate. We see all different, all sorts of ways people fixing this product off. Statement only one way.
Brilliant. Cheers, Rich. Second question for you. How do you determine if the system is installed correctly during the installation? You
test it. So you do a quality control, and anyone doing an INTELLO installation, hopefully they understand that Clima provides a fan, for the WinCon fan, for the builders and the installers to actually bring the building up to pressure and find the leaks and do a quality control on it. WinCon itself, that's just a big fan and a pressure gauge and a speed dial, and comes to site, the builders can then spend a couple of weeks, depending on how good they are, sealing up the holes and finding out the leaks, or before they get the blower door involved and then try and meet the targets. So yeah, test it. Always test it, and the tools are there to test it from us.
Brilliant. So if you are doing an INTELLO project, do reach out to the team. We have got the testing gear available for you to verify the installation, as Rich has just explained. Hey, awesome. Thanks, mate. I appreciate your time. Right, we're going to move right along to our newest team member, Catherine McGregor, based out of Arrowtown, who's going to be presenting to us today on a project that's actually just currently in the build in Queenstown. So, Catherine, please take it away.
Alrighty, so I'm just going to take you all through a high performance build process. So like the chain links of a bike, we all need these to be well oiled, connective and durable. So it's the same with our construction. We need to look at the mechanics of our build, which is our envelope. To build a thermally efficient high performance home, we need to look into three main processes. So firstly, the thermal modelling, so we understand what calcs are backing up our design, the build sequencing, and quality control. This means our envelope needs to be continuous with weather tightness, air tightness and insulation. We do this by identifying and reducing our thermal bridges, which is looking at areas where there is heat escaping to the exterior of our construction, how conductive the material is, and how we can slow this down. The use of good quality windows, which is appropriate for your geolocation, including awareness of shading and solar gains to avoid overheating. Also using balanced mechanical heat recovery ventilation systems. And then we need to back this up with what we have done with a blower door test once the air tightness control layer is in place. And also at the end of the construction. So today we are briefly going over a low energy case study west of Queenstown, using the previously mentioned processes. So the home owners are an architect, Carolyn from CF Architecture, who designed the house, and her partner, Jara, who has been an integral part of the build process. Both of these guys are mountain and dirt bike fanatics, so very cool. They have a team currently working on constructing their home to an internationally recognised low energy build standard. And they have chosen to use our Clima products on the complete exterior and interior of their home, including the underside of their floor adjacent to the ground. And this is to prevent wind washing as the house is constructed on piles. So the windows here, they have brought them in from Germany, and they are timber. And these are placed in line with the insulation. These windows have an aluminium facade to protect the wood, and these are triple glazed, which is needed for their site to achieve the optimal performance for their build. Keeping in mind, window frames are one of the biggest sinkholes in your build, and it's worth investing money into these for any construction. We also, Carolyn and Jara decided to go with balloon framing detail for their construction, which means that the construction has no interruptions of mid-floor or internal walls extruding through the main frame. And this reduces the thermal bridging. The other benefits of doing balloon framing removes the sometimes tricky mid-floor and detailing and the internal wall detailing as well. So these guys are currently installing the INTELLO Plus, and I went out and took these pictures on Monday, and they're doing such a great job. The whole interior will be wrapped in INTELLO for a complete continuous airtightness layer, and they will also be getting this verified in the coming weeks. So far so good, and we're all looking forward to hearing the results. So I guess, you know, why do we do all of this? And it's so every member can return to their home and be comfortable in their environment. So,
Catherine, they're doing a good job because they're trained well, or?
Oh yeah, totally.
By the best of it.
Yeah.
Hey, I've got a question for you regarding this project, and I've fortunately met Caroline a couple of times now, and she's a real up-and-coming architect in Central Otago. My question for you is, do you see a lot of architects incorporating the Clima products in their own personal builds?
Yeah, over the years we've had a lot of architects and builders build their own homes, and we really like to support their own personal projects. I also believe it's important that if you can actually design and live in your house that has all the higher performance components, you can actually feel what it's like to actually be comfortable.
Yeah, fantastic.
Yeah.
Now, don't duck away. I've got a couple of questions for you as well. The first question out of Auckland: how do you deal with kitchen exhaust penetrations through the air tightness layer?
So we have two common ways. The first would be probably the recirculating range hood, and this eliminates having to go through the internal and the external layers of the envelope. And normally this is a charcoal filter system. And make sure, like any outlets for the range hood, there's a dampener installed. So this means when the range hood is not in use, the dampener is closed, which is sealed shut and then therefore airtight. And also around any ducts, make sure there is a Rolflex EPDM grommet, so you can, as you can see in the picture, to create a continuous airtightness seal.
Brilliant, well answered, and it is quite a commonly asked question, that one. So
yeah.
very well answered. Second question for you, Catherine. Is there any installation guides on how the INTELLO junctions fit with the external weather-resistant barrier?
Yeah, there is installation guides for INTELLO and all of our external weather-resistive barriers, as well as our construction detail library on the website. So just check those out. So generally, the INTELLO doesn't connect to the weather-resistive barrier. So INTELLO is connected internally from the floor to the wall to the ceiling. And it sometimes can be tricky to understand. So if you have any particular detail that you're trying to address, then just contact one of our team in your region and we can help you through it.
Brilliant, wonderful. Thank you, thanks, Catherine. And hopefully we'll hear from you later in the presentation with some more questions. So much appreciated. Right, moving up to Auckland now with our specifications manager, Richard Hollard, who's going to be talking about a school project that he's been involved in recently. So welcome, Richard, and I'll hand it over to you, mate.
Excellent, thanks for that, Si. Yeah, so today I'm going to be talking about the use of INTELLO for internal moisture management in schools, as Si's already said. So yeah, that's pretty important because, as we know, schools have, well, in normal times anyway, not when there's a lockdown at the moment, but normal times are full of hundreds of school kids, especially after lunchtime, running around the fields, sweaty and breathing and creating lots of internal moisture. This can have consequences for the building envelope and the durability and the health of the building envelope. So, project I'd like to talk to you today about where INTELLO was used was the Pinehurst School Library. It was built back in 2019, and all the main key players there, as you can see on the screen. And I worked quite closely with both the architect, the construction company, and the installer, Envelop Solutions Limited, on the detailing and installation of the product into this building. So the INTELLO was used throughout the ceiling of the main school library building here. So this is just a shot during the installation of the INTELLO. It was installed to the underside of steel, which actually had a thermal break underneath of it. And you might have seen in other slides earlier in this presentation, in this event, that the INTELLO is usually staple fixed. In this case, that couldn't be done because it was onto thermally broken steel. So we came up with a solution between the installer, the architect, and myself. We came up with the detail of fixing with screws with large washers, which was further supported by strapping as well. So that was nicely fixed and held the INTELLO in place. So it's always important to consider when you're putting a layer like this into a job, actually how it's going to be held in place, the realities of building it at the time. And as you can see there, the tape was partly installed in places, and tape is a pretty important part of making the layer continuous throughout the build, as is making sure that it's continuous around the perimeter of the building and well connected to other parts of the building envelope. So it's a functioning layer. Obviously, INTELLO, as we know, is an air and vapor control membrane, so it needs to be continuous to actually function as such. So in this slide, just showing some of the complexities around installing INTELLO in and around plant and equipment. This is why careful consideration and coordination with plant and services is needed at both the design stage and the installation, the construction stage, to ensure that this layer can be installed continuously, as we were talking about, so that it functions correctly. So trying to minimize penetrations through this layer is pretty important so that it can actually function correctly. It's always hard getting around some big plant and equipment when that's already in place. The installer did a really good job here, getting around some of these things which were installed already. So there was, in some instances, air conditioning pipes and things like that, which had to loop in and out of the INTELLO. It probably wouldn't have been the case if the INTELLO was installed first. But in this case, those penetrations were well sealed by Aerosana Viscon fibre. Viscon fibre and Viscon itself is a paint or spray on seal which can be applied in conjunction with the INTELLO system. So it works well to seal up some of those tricky junctions that tape or the likes of the Rowflex grommets can't seal by themselves. So the finished product looks great, as you'd expect. Beautiful ceiling there with lighting and all the services nicely tucked in. But it's great to know that behind the scenes there's a functioning layer protecting the building structure from mold growth, from interstitial condensation and any other moisture problem that might be apparent without these layers in place. And also, obviously, making the construction more airtight helps with the energy efficiency of the building and helps make the ventilation, heating and cooling much more efficient and effective. So that's the end of my presentation. Back to you, Soren. Oh, sorry, it's not, no. The design guidance. So since the project was built, there was the Ministry of Education have updated their design guidance, which you'll see, some of you will be familiar with this document. It was released in September last year, giving a couple examples here of roof systems. So for warm roofs on steel framing is the preference. For timber framed buildings, the cold roof systems, as we see typically with a truss roof in a house, is an option, and this is also a good option for renovated school buildings as well. And you can see the vapor control layer there as a recommendation as part of that system. So as we know, INTELLO is a vapor control layer, so it can be used on any new or renovated school building which meets these criteria of a cold timber roof structure. And these details are backed up by the details on our website. You'll see there circled a couple of instances where INTELLO is included as part of the detail, and one showing there a vented soffit. Ventilation is pretty important in conjunction with a truss roof where you've got a large cold body of air on the outside of the insulation. Obviously different if it's a skillion roof, but there's plenty of assistance from our website with regards to details, instructions, and also feel free to pick up the phone and give us a call or send us an email for some design guidance or reviewing of plans through the design stage.
Thanks, Richard. Hey, just a quick question from my end. The particular project that you've shown us is obviously a new build. In terms of the design guide from MOE, does that cover retrofits as well?
Yeah, it does. Yeah, it covers, and obviously the rules would apply if it's a retrofit of a timber frame structure, which there's a lot of timber frame schools out there. Bringing them up to speed with the latest requirements of the MOE. So yeah, and we've used already a lot of INTELLO in those projects. We've seen that's been specified and installed in some already since that design guide was updated last year.
Fantastic. A couple of questions for you, mate. How does INTELLO work for the overall performance of a wall build-up with precast versus with timber frame plus a rigid air barrier?
Yeah, so with comparing different construction systems, obviously you've got to look at the same principles apply. We're trying to achieve the same thing with different materials. So if we look at precast, the precast concrete itself is pretty airtight, which should be anyway. And once we seal the joins, that's airtight as a system. And then we always say, if you've got precast concrete, the best place to put the insulation with that is on the outside. Then your dew point is towards the outside. The concrete's warm or it's inside the insulation. So it's hard to compare them exactly, but obviously, horses for courses. If you're building with timber frame, INTELLO, fibrous insulation, it's light, it's easy to construct. People know how to deal with that, and we know that can perform really well. We know, there's hundreds of passive houses around the world built in that sort of manner, high performing. We know we can get that performance out of a concrete wall as well if it's detailed and installed correctly. Obviously, there's differences in terms of cost and logistics of getting it there.
Thank you. The second part of the question from the same person out of Auckland. How does INTELLO help to manage any interstitial condensation behind wall cavities?
So INTELLO, as we've heard from Thomas already, is an intelligent air barrier, air and vapor control membrane, essentially. But what it basically does is it's more vapor tight when there's lower humidity. So it stops vapor getting into there. Vapor moves through constructions in two forms, through air movement, air convection, and through vapor diffusion. So mostly it moves through air convection. So if we make it airtight, straight away we've reduced most of that moisture from getting into there, but also the vapor side of things. The product is also more vapor open and more like summer conditions where the humidity is higher, so it allows drying, so it doesn't trap the moisture there. And that's a big one. You could go chuck a total vapor barrier there, and that'll work differently because it won't let moisture out. Which, if we're building mostly with moisture affected products like timber, then we've got to be treating our construction properly with regards to moisture control.
Thank you. Cheers. Another question for you. This one in particular is a bit of a hot topic in the industry at the moment, Richard. When the insulation is on the outside of the building, how does the ProClima product layering change? We've got a couple of examples here. Standard construction, internal lining, cavity, INTELLO, framing and insulation, rigid backing, external cavity cladding versus external insulation, internal lining, framing, rigid backing, question mark, external insulation, cavity cladding.
Yeah, it's a good question, and we're seeing externally insulated constructions now. As I was just talking about with concrete, it's ideal to put the insulation on the outside, not the inside. But in this case, I was involved with this project, Auckland City Mission. This was a CLT building, so cross-laminated timber, solid timber, just about to open, and it's going to be a great asset to the city there with home for homeless people. But the construction in this case was, the CLT, the external adhero self-adhesive underlay, and then the rock wall insulation on the outside of that, which is an insulation designed to be used outside the weather-resistant barrier. So in this case, your weather-resistant barrier becomes your airtightness layer. The big change is that you've shifted where the dew point occurs in terms of location. So by putting the insulation on the outside, the dew point still occurs within the insulation, but it's on the outside of the frame, so it's away from the structure. So one thing to clarify there, because it's often confusing and you can be sort of misinterpreted, is that you can't change the temperature at which the dew point occurs unless you change the weather, which that's probably happening too. But you can change where that temperature occurs. So if you chuck the insulation on the outside, then you're making the dew point occur further out away from the actual structure. So in this case, getting back to the question, the external weather tightness membrane, in this case the adhero, becomes your internal air tightness membrane, and behind that obviously the CLT. So it's pretty important that all the penetrations through that layer are sealed up, just like we do with INTELLO, so that it's actually functioning as an air control layer. So in this case here, there's little brackets, the pins that the insulation is stuck on with. I've got a Nidect seal tape underneath there, both for weather tightness, but also it makes it airtight as well. So,
thank you. Next question. This one's come from Southland, down the deep dark south. Is there a need for INTELLO if using adhero over PIR panel over rigid air barrier as external weather tightness insulation envelope to the exterior timber walls? Now, I know you somewhat answered that in the previous question, but if you just want to just wrap this one up as well, Rich, would be great.
Yeah, sure. So, I mean, I guess the key point to remember is that INTELLO is not a silver bullet. You don't just use it, you don't have to use it in every situation. In some constructions, another product will take the place of it, or have be filling that property as far as air tightness. If you're using a PIR installation that's more vapor tight, and generally you don't use INTELLO with a vapor tight installation. INTELLO is designed to be used with fibrous insulation and stick framing. So a fibrous, a vapor permeable type construction. So generally you wouldn't use INTELLO to the inside of a PIR installation that's put on the outside of for external insulation, unless you were then further insulating on the inside of that with a fibrous insulation. So if you're putting PIR on the outside of a RAB, and then you're putting some pink plats or whatever inside the frame to bulk up the to get the R value up to required level, you could then put INTELLO on the inside of that, because you're shifting again where that dew point occurs back into the framing. And what INTELLO does is stop that moisture getting to that stage where the dew point can occur and interstitial condensation can occur.
Very well answered. Thanks, Richard, and we'll see you later in the event to answer some more questions. Righto, we're moving off onto Simon Cator's presentation. Simon, as mentioned before, is another member of the Auckland team based out of our wonderful training facility, which is Notion One in Penrose. Simon is presenting today on a recent project he was involved in Rotorua. I'll hand it over to you, Simon. Take it away.
Thank you, Si. Yep, great to be here this afternoon. And yes, this afternoon we're talking about a project in Rotorua. Ian and Raywin, they had lived on this section for 24 years and decided they wanted to build an energy efficient home on the front of that section. So when they sat down and discussed this with me, we talked about the benefits of having an airtightness layer to create an energy efficient building. So INTELLO plus airtightness layer was a key element. Alongside of that, they needed some ventilation, which is always important if you're creating an airtightness layer, or even if you're not. We always need to consider ventilation, how the building is able to do away with the old stale, damp air and replace it with fresh air. So they used a Zender system for that. The walls were well insulated. They had an R4.1 insulation using Knauf insulation, and a 45mm service cavity on the inside of the INTELLO layer. In the ceiling, they went for a Jetstream Max, which is a blown-in insulation, and that is blown in above the INTELLO layer and offers a really nice, well-distributed insulation layer. For windows, they went with a double-glazed UPVC window from NK Windows. The UPVC frame offers a really good thermal break from the cold air on the outside, and they thought about the slab as well. They went with a Maxraft fully insulated slab system, so they were creating a good insulation layer all around the building. So if we have a look at that INTELLO layer and the components that make that up, so we've got a really good installation guide that we've released now on our website, so feel free to go and check that out. This system includes the INTELLO Plus, the actual intelligent air tightness and vapor control layer. All of the laps are taped using the Tescon Varna tape, and as you remember, Si told you it's got the 100-year adhesion testing. We use the Tescon profile to connect the INTELLO off to the window frames, and the Orcon Classic adhesive is used to make sure that we connect the INTELLO off to the floor layer. At any penetrations, we use the Roflex pipe seals, both on the inside for the INTELLO and the outside for the weather resistive barrier. We then created a 45mm service cavity on the inside using timber battens. When we tested this project, the blower door test came out at 1.3 air changes per hour, which compared to a standard new build without a dedicated air tightness layer, we could expect anywhere between 5 and 7 air changes per hour. So I gave the homeowner a call recently just to find out how he was finding living in the house after 2 years. And his comments were, first of all, that it was really quiet to live in. It was improvement on the external noise coming into the building. Secondly, it had improved its performance. He was using only two 2-kilowatt panel heaters, one in the lounge and one in the passage, and those were maintaining a really comfortable temperature for him. His hot water was heated by a gas system, and he also is really enjoying his home automation system, which is regulating the lights, the blinds, and the heating. And what it's also doing is a clever little function. When he switches the bathroom light on, it actually boosts that ventilation system to make sure that he gets rid of that extra moisture that's created in the bathroom. Thank you, Si. Back to you.
Hey, thanks, Simon. Just a quick question from me. Through the design process of this project, was it designed to be like of a passive house, Simon?
No, so this is not specifically designed as a passive house, Si. It's a standard construction, but they've decided to upgrade various elements of the building to provide a far greater energy efficiency than a standard code build.
It would have to be one of the best performing houses in Rotorua, wouldn't it?
I would think so.
Right, mate, couple of questions for you. Why is INTELLO applied to the inside of the framing, and what makes it an intelligent vapor barrier?
It's a good question, Si. So the INTELLO is designed to be an intelligent vapor control layer, not a vapor barrier. So vapor barriers are a complete block to vapor movement. We want to have a vapor permeable or a vapor variable product. So the INTELLO actually varies its vapor permeability based on the seasons. So when it's a winter season, warm inside, cold outside, that warm moist air is trying to get towards the outside of the building. What happens then is the INTELLO effectively tightens up and stops the moisture from moving into the insulation layer and reaching the dew point. We've got a really good little video on our website that explains this in a really graphical format. The other side of it is when it's summer and we've got warmer air on the outside trying to move inwards towards the building, the INTELLO will effectively open up and will allow that vapor to move out of the construction.
Brilliant. If I move just to the side here, Cator, I think the image explains exactly what you've answered. The second part of the question from JK in Auckland is also, how does the price compare to other conventional barriers from competitors?
So, Si, we haven't really seen any of the major manufacturers coming up with any products to compare with this at the moment. So hard to say at this stage.
Okay, well answered. Thank you. Another question for you, Simon. What's the cost, including the installation?
So that's a really good question, Si. Airtightness is actually the most cost-effective way of improving the performance of your building. We estimate approximately 1% of the build cost for the INTELLO and installation, and it's therefore a really good way for New Zealanders to actually upgrade their homes to a much higher performance.
Brilliant, thank you. Now, we have a poll question coming up, Cator, which you're going to kindly read out for me. So far away.
So we're wanting to know from the audience today, have you specified or worked with INTELLO before? So you'll see there's two answers there, either a yes or a no, and we'll appreciate if you can just click on one of those buttons and press the submit button, which will push that through to us, and we can see what your results are. Si?
Oh, if you could kindly read those results out when they come through, Simon, would be great.
Yes, so there we go. 65% of today's audience has worked with or specified INTELLO before, which is great. And then another 35% who haven't. So let's hope after learning about it today, they might want to consider that when they discuss the next project with a client.
Thanks, Simon. We'll see you at the end of the event to answer some more questions for us.
Awesome.
Rightio. Moving right along, I'm going to hand you over to Soren Webb, who's our regional manager in the lower North Island. He's going to talk about quite an exciting project, this one, a commercial-based project that's recently been undertaken in his region. So, Soren, I will hand it over to you.
Thank you, Simon. I'd like to introduce the new office and staff facility at the Silverstream landfill for Hutt City Council and Waste Management Limited. This is New Zealand's first Passive House Institute certified low energy non-residential building. The client considered refurbishing their existing building, which was cold and drafty in winter and hot in summer. Isodone Homes offered a more cost-effective new 150 square metre warm and highly efficient, healthy building. And this is obviously really important for the staff who work in the exposed landfill environment. It's a fairly architecturally utilitarian building. It has a boot wash by the side entrance. The internal design offers flexible staff meeting spaces with sliders between the two areas that may be opened to provide a single larger space. The building features the latest technology. Isodome foundation slab has R7.7 of insulation with 250 millimeters under the slab and 50 mil slab edge insulation. It's even greater once you add the concrete. The 250 mil block walls with 150 mil reinforced concrete core offer R3.6 filled. The skillion roof assembly is best practice counterbatten and purlin above sheathing ventilation setup with Solartex Mento 3000 on sarking and R5.2 Canal Jetstream Max blown in insulation. You can see the gap between the double fascia where the roof cladding ventilates. The roof cladding terminates into the gutter. The Mento underlay terminates over the inner fascia. And of course, the cavity is vermin protected at the eaves. INTELLO provides the internal air tightness and moisture management for the skillion roof assembly. Here you can see services, including ventilation system ducts, are run within the thermal envelope. The Zenda Q350 heat recovery ventilation system was selected for its low noise performance and cost-effective pricing. Isodome supplied double glaze, argon-filled, ideal twin set 5000 aluminium faced UPVC windows from Aluplast. These are taped internally and externally with Proclima tapes, and you can see they're recessed into the wall thermal line. The hot water cylinder is fitted with an air to water CO2 heat pump by Reclaim, and the exterior is finished with Stowe R-Mat render coatings. We not only engage with specifiers, we're also keen to engage on site. In this case, we assisted the quality insurance process with both our WinCon fan and the Minneapolis blower door. If you'd like to know more, there's a case study on Jason Quinn's sustainable engineering website, and there should be a link to that in the chat window to check out. Thanks.
Soren, fantastic project there, mate, and quite unique in a way that the particular projects use two different systems to create the internal air tightness layer. Is this very common?
No, INTELLO is quite often a critical component in maintaining the continuous internal air tightness and moisture management system. It's common with both ICF block, straw bale, SIPs and CLT construction. So it's perfectly normal.
Brilliant, wonderful. Right, I've got a couple of questions coming for you too, mate. What is the recommended service cavity system to install over INTELLO? Timber battens or a metal rondo clip system?
It's a good question. So quite often we see different systems for different assemblies. So for the ceiling, it's quite common to use the rondo, and that allows you to create this suggested gap between the potentially recessed luminaire and INTELLO. We've got an in-service temperature maximum of 80 degrees C for INTELLO, and most luminaires, the best ones will be ICF for covered and abutted and fine fibre rated, which only tells us that the luminaire or the driver pack is going to be below 90 degrees, so it doesn't really help. So typically we're suggesting an air gap, and you've got quite a bit of flexibility with the metal ceiling grid systems to adjust that accordingly and include spacing for ventilation system ducts, etc. For wall surface cavities, timber batten is most common, and that's generally 45, because 45 millimeters plus minimum 10 mil internal lining thickness would meet the electrical code requirement of a 50 mil screw being able to go through your internal lining without livening up on any of your wires which are running within the surface cavity in front of the structural framing.
Thanks, Soren. Another question for you. How does INTELLO improve framing moisture management?
Okay, so I think we've covered that pretty well. It's 99% of the way it's working is airtightness. It's also preventing drafts and convection airflow. It's managing diffusion in a smart way through the humidity variable smart vapor check function. And this allows back diffusion drying in summer or on a hot day when the cladding cavity temperature might exceed your internal temperature. And there's no negative aspects of INTELLO. It will always improve in assembly. In some circumstances and climates, it can be a critical component to the durability of that assembly, preventing internal moisture accumulation and potential mold growth.
Wonderful, thank you. Another question for you, Soren, come from Auckland. What does Mento 3000 do that others don't when compared to other roof underlays regarding moisture management?
Okay, so there's a number of points of difference. Key would be 90 days UV resistance for the Mento 3000. This allows you to protect the framing during the construction phase. Competitors typically offer a much smaller window, so around 7 days is quite typical, so it's not really possible. The triple layer construction with the TEEE monolithic membrane, that membrane is 10-meter water column tested. Other products are often engineered for the code minimums, which are 100 mil water column for roof, 20 mil for walls. So this offers a huge benefit compared to the microporous underlays. And we see that with the monolithic membrane, means that moisture will not wick into the insulation or the substrate. So you don't need the usual gap between the underlay and the insulation if you're doing a skillion roof assembly. So this is unique to the Mento products, and it allows the best practice detailing is covered by our independent BRANZ appraisal, as well as the E2AS1 acceptable solution direct fix detail, which you'll do with any other underlay. So you can certainly use the nicest underlay for the standard direct fix detail as well. That's important. We have an adhesive version with 180 days UV resistance. That's our Extasana Adhero. It's also BRANZ appraised for the roof application on a solid substrate. So perfect for sarking, rigid substrates such as SIPS panel. And it's also worth mentioning that we don't really work on a sort of a product basis of just simply supplying a roll of underlay. We've got a holistic whole system detail approach with Nidec for sealing the purl and screw penetrations underneath the counterbatten. We've got a Connect version of the underlays as well with the double-sided tape for the laps, or the option of simply taping the laps with our Explorer flashing tape.
Perfect, thanks, Soren. Stick around, we've got some more questions coming your way. We are just going to move into the straight Q&A session. We've finished with all the short presentations. We've got a number of questions that are going to be asked to our panel. As I mentioned earlier in the event, please, if you do have any burning questions, put them up in the question channel. We may not be able to get to them today, but one of our team will do so directly with you. The other thing, Eva's just going to load up a link to the new INTELLO booklet, so please feel free to click on that and download that, and always happy for feedback on anything we do, so it'll be up in the chat channel shortly. Rightio team, we're all back online. The first of the questions I have here, actually I might ask this one to you, Thomas. If you have minor defects in the vapor barrier, can having a vapor barrier do more harm than good?
Interesting question. So first and foremost, INTELLO is not a vapor barrier, but if we're just talking about the terminology in general, Often you have small penetration points, so you have fixings going through, you have other things happening. So in the image that you see there, where you have an internal batten fix, the screw fixing through the internal batten through the INTELLO into the framing is actually covered through the batten, so that's not an issue. Also, if you think about, I have my flip chart, but I think I'm not allowed to use it. If you have small loads of little penetrations, if you think about penetration hole, there's a lot of friction around the opening. So what's actually of more of a concern is if you have a large penetration than loads of small ones. The other thing, the good thing with the INTELLO is that if you would have small penetrations where you have the water vapor getting through airflow, if that is happening, because of how the INTELLO functions, we can actually adjust the moisture loading will be adjusted, so it's not that at one particular point where you have the penetration that suddenly everything goes wrong there. Maybe one suggestion I could make, Simon, is that there seem to be a lot of questions around the details of how the INTELLO actually functions. So I'm more than happy for us to maybe load up a detailed function workshop or something if people want to know how the molecule structure works and everything. So if anyone wants to go into the nitty-gritty part of INTELLO, happy to run a separate workshop where we can maybe also do some woofy simulations if anyone is interested.
And if you don't have the 5 hours needed to sit in on Thomas's science lesson, you can jump on YouTube and type in INTELLO function, and there's a very good short video clip explaining how the INTELLO actually works. So
it's
probably
all right,
a better
but
option.
not as detailed as it can be.
Rightio, we have a question coming your way, and Thomas, I would ask you kindly if you could please read the poll question out and the answers.
So we have our third poll coming up, and the question is around what have been the most significant challenges in specifying or working with INTELLO. The question or the answers that you can tick there is none. I haven't experienced any challenges, which sounds really good. Client builders, others don't understand what INTELLO is for. Then, of course, we have the usual cost cutting, and then the consenting issues, maybe RFIs or other things. And other could maybe tick, I have not worked with INTELLO before. So if you can just click one of those 5 answers, then we can also go through to the overview once we have those. So
just to add to that, Thomas, if we haven't covered any of the points in that question, please feel free to submit your suggestions or your current situations that you may have experienced into the chat channel. It's always good to have the feedback so we know where we can support you guys better.
All right, so now we're getting to the answers. Interesting, 4% of the people who answered have not had any challenges whatsoever, so that's a really good one. Majority is around client builders and others don't understand INTELLO is for, so that's clearly an educational thing that needs to happen. Cost cutting, again, maybe there's a misunderstanding of what INTELLO actually does and how vital it is to the durability and therefore also the wider sustainability aspect of the building. And we had about 33% who have not worked with INTELLO before. So thank you very much for your feedback.
Thanks, Thomas. Hey, just to, you know, we have gone over our hour and a half scheduled time. We are going to continue on and just answer the remaining questions. So please do hang around to the end. Like I said at the start of the presentation, if you have got any questions that you would like to ask, please feel free to submit those in the question window and one of the team will come back to you later on. Rightio, question for, probably best for you, Rich Eden. Is there anything we need to be aware of when using INTELLO in prefab construction? Any details available? So a couple of questions there for you, mate.
Yeah, thanks, Si. Yep, a couple of questions there. Prefabrication, you're building panels off-site and then you're transporting them to site. Of course, during this transportation and pre-build phase, you're going to have to protect them, right? You're going to have to protect these panels from transport damage, so skids and things like that, and then also weathering damage as well. So making sure that these panels are nicely wrapped up is paramount to the durability of the actual envelope which you're transporting. One other note would be, which I've come across a couple of times, is when doing a service cavity, like in the picture there. They've done the service cavity at the very end, and they haven't actually allowed any lap coming out with the INTELLO, so that when they stand the panels up, you've got two service cavities butting against each other, and you can't actually connect them off. And that doesn't get noticed till later on, and they have the WinCon fan going. Of course, all of our details really can be applied to prefabrication off our website, so go and check them out, give me feedback. I'm always keen to hear about the prefab, and if there are any details which are missing as well, which would support you guys.
Fantastic. Thanks, Rich. Just so you're aware, we are heavily involved with prefab construction in New Zealand and around the world. So if you are a prefabricator or need assistance, please feel free to reach out to one of our team. Rightio, next question. I think this could be a good one for you, Richard Hollard. How can we import the performance of INTELLO into software such as Woofy?
Thanks, Si. Yeah, so luckily for Woofy users, the hydrothermal modelling software users, the INTELLO is already loaded in there as a product, so that'll have all the vapour characteristics loaded in there. So if you're putting in INTELLO into a Woofy simulation, Woofy model, into a water, then it's got the known factors, it's all loaded in there. And more recently, the external underlays, the weather resistive barriers, the likes of the Mento and Extasana and that sort of thing, are loaded into Woofy as well. So that's a big help for that stuff to be loaded in there already. You can make your own product in Woofy and with known factors, but that's all done for you with regards to the ProClimate products.
Brilliant, thanks, Richard. Second half of the question, which you can feel free to answer as well. How do you have regional Pacific Woofy data to inform details? If not, when will these be available?
So yeah, Woofy is relevant to anywhere in the world that you're using it. For those who don't know about Woofy, there's probably a link up in the chat channel now, but feel free to give us a call or go to our website to check it out, or woofy.co.nz as well. But Woofy hydrothermal modelling works on local weather data. So in New Zealand, they've loaded into Woofy the NIWA weather data. Now, just to be clear, obviously Woofy is developed by Fraunhofer, which is like a bigger version of BRANZ in Germany. It's a research facility. And in New Zealand here, BRANZ are the corporation. They cooperate with Woofy, Fraunhofer, and ProClimate is involved in training people in using Woofy, and obviously we're promoting the use of it as well. And it's a really good tool to use to check your construction from a moisture safety point of view before you actually build it. So it's all about check first and then build to avoid mistakes and things happening with your construction later on. So in New Zealand, the weather data is there. If you're planning to build a house in Hamilton or Invercargill or Cator or anything like that, you plug in the address and basically the NIWA data specific to that region will be there already. And that's updating. It's based on a typical year as well, so they're updating those weather files all the time. So it's always very relevant and accurate for exactly where you're building. So you put in the weather data, you put in the location, you put in the products you're using, and obviously what's happening inside, so orientation, all that sort of thing. So it's always exactly relevant to what you're doing.
Cool. Thanks, Richard. And if anybody needs a Woofy simulation undertaken, you can access on our website the Woofy users that are scattered throughout the country. So feel free to jump on there and you can engage directly with them. Rightio, next question. Simon, I think this will be a good one for you. What should be the location of the interior INTELLO relative to the insulation to avoid dew point in the wrong place?
Good question, Si. So if we look at this detail on the right-hand side of the screen here, you can see that we have the INTELLO installed on the warm side of the insulation. And when we talk about the insulation, we're talking about the main insulation. In other words, the large proportion. And we have a rule of thumb that we talk about. which is the 1/3, 2/3 rule. In other words, at least 2/3 of the insulation must be on the outside of the INTELLO. We then have a further 1/3 on the inside in the service cavity, and there's some benefits of that because you're cutting down on the thermal bridging of the timber framing. And because it's only up to 1/3, the dew point will still be located within the major insulation layer, which is on the other side of the INTELLO.
Thanks, Simon. I think you've pretty much covered the next part of that question, so I don't think I actually need to answer it. So wonderful. Thank you very much. Oops, sorry, wrong way. Next question. Is there anyone that can come locally to do on-site training with myself and team? Now, this question's come out of Queenstown, but I will ask Anthony if you can answer this, considering you're the man that manages the training and education side of ProClimate in New Zealand.
There's multiple approaches we have to training. One is on specific on-site training. So we're quite happy to get our sales team to come and visit you and do some on-site training. We do also have some short courses at our training facility at Notion 1 in Auckland, where we can actually accommodate normally around 6 to 12 people and have some in-house sort of practical and theoretical type training programs as well. So feel free to get hold of us and contact us, and we'll actually work out what's the best solution for your particular team. So get hold of us and we'll go from there.
Cheers, Anthony. Just to add to that, we do have the ProClimate Cube as well, which is a 20-foot shipping container converted into a seminar and training facility, which we operate out of through most regions in New Zealand. So please keep an eye out on the events page on our ProClimate website to see when the Cube is going to be in your region. Another question here, and I might keep this with you too, Anthony. What is your recommended transition to membrane roofs and decks?
We have a really good understanding of our products and what they can and can't do. We have very little control of what other people do with their products, and for us to be trying compatible with every type of membrane or type of tanking is pretty hard for us to do. So what we do recommend is we do recommend a metal flashing of some sort, which acts as a transition between the actual membrane and also the underlay that's on the wall. And in doing so, you actually physically isolate the two, and you don't have any compatibility issues. So we know our products actually work well with that kind of system. And certainly, if you've got any details that you want to go over, our team are quite happy to help and actually give you some advice on how that transition should happen. So every single detail is different, what we're finding. So it's just a case by case, and let us know, and we can actually work through some solutions for you.
Brilliant. Just to add to that, there's a lot of the construction details are on our website as well. So feel free to jump on the resource centre there, and you can download the details that are according to your project. So another question, probably a good one for you, Rich Eden. Do you have an underfloor product, and if so, how is it installed?
We don't necessarily have a specific product for under your floor, but what you're trying to protect there is your insulation from wind wash. So per the new details on our website, which I put together, the foundation details, you'll see a detail for, say, pole construction with crawl space, where we have our wall underlay, the Solitex X Designer, installed underneath the insulation. And what that is for is to stop the wind washing of the insulation and damaging your R values, and supporting the warmth of that floor.
Awesome. Thanks, Rich. Next question. I'll get on here. Is the system suitable over concrete blocks or concrete panels? Rich, well, let's leave this with you. If you can answer this one, would be great too. Thanks, mate.
Yeah, so it's an interesting question. It is concrete blocks. The Hollard touched base on this a bit earlier. To really reiterate is INTELLO itself, and understanding that INTELLO is typically used for residential commercial buildings where fibrous insulation is installed and you have a bidirectional moisture flow. So where you've got climates, cold on the outside, warm on the inside, and changes vice versa during the seasons. Not so much when you have the likes of a heated swimming pool. At a heated swimming pool, you're always going to have a higher pressure on the inside of that envelope, and so you're only going to have one direction of moisture. In those types of situations, INTELLO being a product used for bidirectional moisture flow isn't really suitable. So for heated swimming pools and things like that, you might want to look at something which is more of a blocker or a single resistance, which is required. Concrete blocks and concrete panels are generally the same. You know, they're completely airtight, and you've got a lot of concrete there, so you might not have that bidirectional moisture flow. So not really as suitable. What we can say to them is to ensure that that internal surface face is not your dew point. So make sure you're putting the insulation on the outside and keeping that internal surface temperature warm.
Brilliant. Thanks, Rich. Rightio, next question. Rich, you might as well answer this one while we're at it. Are there some techniques to install INTELLO to maximize durability so that any damage or tearing to the INTELLO caused by movement in the home structure, say due to earthquakes, etc., is minimized or avoided?
Yes, there are. I'd probably put forward the question first on how much are you expecting this wall to move, and if so, making sure that the product that you put in place for your bracing can handle it as well. The INTELLO itself is a flexible membrane which has ductility in itself. If you are expecting to have a lot of movement, and we have with tiny homes and trailer homes and things like that, where these constructions do move around a lot, we've told them to use our adhesive, the Orcon, and keeping a nice thick bead of it there gives a massive amount of ductility and stretch onto these membranes as well, while still holding them in place and keeping them airtight. So yeah, definitely options available.
Cool, thanks, Rich. Next question, probably a good one for you, Thomas, the in-house blower door guru. Do you know if an air tightness target and air changes per hour will be part of the next building code revision in 2022?
I need to get my crystal ball. I think what we've seen outside of New Zealand and also now New Zealand, so starting outside, I mean, we have clear targets in all OECD countries I lived and worked in, except New Zealand at this point in time. Australia has some targets already introduced for residential and commercial in particular. We have some clear guidance from MB on the from the Building for Climate Change group. So what we're looking at is 2030 to basically design and build houses to passive house performance standards. So you will see the 15 kilowatt hours per square meter in annum. To give you an idea, BRANZ is already recommending a threshold of 3 air changes per hour under 50 Pascal. So that has been, as of the past few weeks and months, being published from BRANZ's side. Passive houses 0.6. So basically, we have no uncontrolled airflow through our building fabric. So I would say New Zealand will definitely head towards international minimum practice, which will be 3 air changes per hour or 1.5 or less if you have a balanced heat recovery ventilation system. But MB is clearly pointing out we're heading towards passive house performance, so that's 0.6 air changes per hour. So that's not easy to achieve, and you can only achieve high levels of air tightness if you design it properly, if you execute it, so install it properly as a system, and you verify it. So Richard even was talking about that you have to do testing before your internal lining goes on. So best thing is to test twice. When the INTELLO is installed to ensure it's done properly, and then for a whole house verification with the blower door later on.
Thank you. Cheers, Thomas. Well, everybody, we've really well and truly gone over our scheduled time. Too many fantastic questions that have been submitted by all of you, and I know there's been a lot more as this event has been running. If you do wake up in the middle of the night tonight with that light bulb moment and have a question, please do reach out to the team. We're here to support you. Keep an eye on our events channel on our website for future and upcoming events. make sure you jump onto YouTube, to our Proclaimer YouTube channel. You'll see my INTELLO episodes being loaded up there on a regular basis. I believe the first one went live earlier this week. Connect with us on Facebook, LinkedIn, and any of the other platforms that we operate on. We'd love to hear from you and hear feedback. And do take the time, if you get a chance, to jump onto our INTELLO survey and give us some feedback so we know how to support you better in the future. But thank you very, very much for sticking with us for so long. And thank you to the team as well for answering all of the questions and sharing your presentations with us. It was an absolutely wonderful event. And stay tuned, there's more to come. Thank you.
Thank you.
See you guys.
Thanks, everybody.
Bye then.